Let me get this in full screen. There we go. Thank you for the introduction. So yeah, I'm going to talk about Kubernetes in production at Blendle. Hello, good day. Thank you for being here. My name is Bollen from Blendle. Today, I'm going to talk to you about Kubernetes. So I myself am a backend developer at Blendle. I'm not actually part of a DevOps team or anything that. I code most of my days. My history is in game development, so I like things to be really fast. So within Blendle, I do performance stuff as well. I'm going to talk to you guys about our history with Kubernetes at Blendle, what our current setup is, what we want next, what do we expect, what do we miss, and some tips and tricks along the way. Two things first. One, who here uses Kubernetes already? That's a 1, 2, 3, 4, 5, 6. Around 10 hands. Who here wants to run Kubernetes or plays it with it at home? Okay, that's good. Thanks, good that you're here. First, a little bit of context on what Blendle is, so you know what kind of company we are and why we do this in Kubernetes. Blendle is a Dutch startup. We're located in Utrecht, and we sell journalism articles from newspapers and magazines, and we sell them to you per article. So you buy this one piece for 10 cents from this publisher, and you continue reading from another publisher. So what we do is we aggregate all their content, all their data into a useful format, which we then present in our mobile apps and on our website. And users can read, pick and choose from all kinds of newspapers. We're currently at 3 million users, active and running in the Netherlands and in Germany, and we're currently in our closed beta in the United States. And our mission is to help you discover and support the world's best journalism. For example, who here pays for their Spotify or Netflix media consumption? That's basically everybody. Who here pays for their digital journalism? Oh, that's actually quite a good amount. I'm actually surprised at it. We want to make that as usual, as normal as Spotify, so that journalism can survive, which is kind of important, they say. Looks a little bit like this website, separate articles in the style of their newspapers. So that's about Blendle. When and why did we start using Kubernetes? By the way, I'm going to use the abbreviation a lot. You might have seen that on the web. Because if I would spell out Kubernetes there, it wouldn't fit on my slide, so I had a big problem. That's okay. Quite a while ago, I think 1.5 years ago, we decided to launch a separate product, a side product for Blendle, called the Blendle button, where newspapers could include our payment system on their own website, their content. So users on the website of the Volkskrant or the Times, you can then unlock this paywall with your Blendle account. So you don't have to make an account at every news site you have. It was a new API, it was a new client, it was a new product within Blendle. So we thought this is a great time to do something new, and we started working with Kubernetes. And this was in version 0.9. And it was horrible. No, it was not horrible. It was very beta, and we were very new with this. So for us, it was very new as well. So it was some struggling, but we actually, even though it was difficult to begin with, we immediately really, really liked it. And the side project gave us an amazing trial run with this Kubernetes thing we've been hearing about. And then a few years passed. And now, currently, most of our running infrastructure for our apps, like our backend or microservices, run on Kubernetes. way in the beginning of Blendle, we started actually running on bare metal with our own database, our own monolith backend. We actually ran that at LeaseWeb. Then we moved to AWS because we thought databases isn't our core business. We want to outsource that, which we were already really happy with. And then we moved to Google Cloud Engine because we wanted to use Kubernetes. And currently we're at 1.6, so we're trying to keep up to date. And it is less horrible. No, it's actually really great. Yeah, so it took us 1.5 years for most of our important infrastructure to get running in Kubernetes. More on what that exactly is later. One important thing what we did is first lift and shift our AWS infrastructure to Google, so we could then move small parts to Kubernetes within the same network. Because moving small parts from your infrastructure to a entire new system and a new network was too much hassle for us to do both. So we switched first to the provider where we were going to run Kubernetes. That was really useful. And things we don't run in Kubernetes, we don't even want to run ourselves, are things like managed databases or Redis or stuff like that. Google has now a fine SQL Postgres service, and we do run some Redis in Kubernetes, but those are hot caches, which may drop down any moment, so that's fine. Now, our current setup. So we run the Google Cloud Engine, Compute Engine, Container Engine, and it's with a K because the C was already taken, the acronym. And one of the things you get if you do the gcloud containers clusters create command, which you saw 2 talks back here on this stage, is in Kubernetes you have a master node and a couple of worker nodes. And the master node is completely managed by Google. And we don't even have access to that machine if we want to. And this is actually really nice because on a side hobby project of mine, personal one, I did it myself. It was not that difficult to set up, but then doing upgrades, etc., was a hassle, basically. So we really like that they manage our master node. We're running 9 nodes now. Staying up to date as fast as we can, mostly because we want the new features. We are anticipating, looking at pull requests on Kubernetes itself, seeing, oh, we want this feature as fast as we can. And we're now running 1.6.1, and we mostly wait a week before updating. So we wait until the major bugs are out, and mostly within a week. We think it's safe to update, which goes seamlessly. It takes about an hour, half an hour to upgrade our entire node cluster of nodes. Just roll them, update them. It's really painless so far. I probably just jinxed it for the next upgrade. I'm sorry for my colleagues. Yeah, one of the more exotic things we do is most of our nodes, actually only 2 are regular nodes, the rest is preemptible. That's a type of node at Google where you say I want preemptible nodes, and they are very volatile. They are computers Google has lying around, which are really cheap, but they at most live for 1 day, and you don't know when they go down. So if you have a preemptible VM, and you're working on it, and it will just shut down, and it's gone. And 7 of our 9 nodes are preemptible nodes. So as I speak now, one of those nodes might die, or 3 at once. I saw that I always have like a terminal window of all our services in Kubernetes, and I saw a couple of going down. So, oh, it's a preemptible node going down, and then I saw a couple of more, and then another couple of more, and then 3 nodes within 15 minutes just went down, and new ones came up, and that worked. And that's one of the Kubernetes things we are really happy with. They save us a ton of money because you get 75% off if you check the preemptible checkbox. So they are really cheap compared to the rest. But that's not even the best part around it. It's the least best part of it. Is it also forces us, it really forces us to make good software, versatile, robust software that expects to fail every now and then. So while I'm coding, I'm writing a loop. I am aware that this might break down right now, what will happen then? And I have to prepare for that or think of contingency plans, etc. So it helps us all make great software. And our uptime is really low, a day for those nodes at most. There are some issues with it that cause some hurt. One of them is they tend to get into sync and dying all at the same time. So we wrote a little bit of software which warns it when the uptime of these persistent preemptible nodes are around the same time. So we know it will just kill the 3 manually every now and then, so their time window spreads around the day. And that's something we learned the hard way. Another thing is, if you have like a very small application which is really lightweight and it doesn't do anything but it has to keep running, you can't just have one replica of that. You can't have one pod running it because it might die and it will take a while for the new one to get up. So even the smallest of applications, we always run around 3 replicas at least. For the software which isn't allowed to use this, we are bound to have only one replica of it, while we have 2 other regular nodes. And in Kubernetes, you can do something called node affinity and say, well, this pod, I wish it to run on these types of nodes. And we have a label that says it's not preemptible. And it will check to run on one of those nodes. So for a few pods or services, we run on our regular nodes, which we know tend to stay up longer. One tip, if you're going to do this, is improve on your health checks for your services. That actually check the health app, not just return OK, or that actually check the connectivity to the database, if it's still running, etc. Because the better Kubernetes is aware of your state of your application, the better it can move pods around. So yeah, that's really important. A fun fact is that preemptible nodes were never meant to be used in a Kubernetes cluster. It's something we tried out and found out ourselves. And we're really happy with that. So that's how we're running it. So what do we run in Kubernetes? I would really would like to say everything, but I'm afraid I would be lying then. We're trying to move more and more there. So I hope we ever end like this, because we really like it. No, we moved our main services for the platform itself. So if you use the mobile app or the website, you run on Kubernetes. So our core monolith, our legacy backend API, and all our microservices. And we're currently in the process of removing features from that core monolith and putting them into new microservices. And Kubernetes really helps us with that, because it's really effortless to make a new microservices and connect it with our system. It works really well. I do want to note that getting this core monolith to run on Kubernetes, that took some time and fiddling around. More on that later, because I'm going to quickly talk about that deployment strategy. At Blendle, we also have a recommendation system where every day you get a selection of articles which we think you want to read, which is really useful. And that entire system also runs in Kubernetes. It's a streaming process. There's a Kafka cluster, a streaming service, and small processes just handle messages. And at the end, a selection of articles is made per users. And we create over 1 million of those bundles each day. And it all flows through Kubernetes using Kafka. But also a lot of internal tooling, like our support tool, our support people use, and our Slack bots and everything. Because it's just easier to put it in Kubernetes once you have it up and running and know how to use it. So yeah. Things that don't run in Kubernetes yet are our ETL, still runs on Redshift at Amazon. And we have a large process that emails users in the morning, and we are in the process of moving that to Kubernetes as well. But that's a large job that is fired every morning, and we didn't decide to put that in Kubernetes yet. So yeah. Did I miss anything? Yeah, one thing is every now and then when you need a machine to do something, to curl or some background job, we just spin up a manual pod. Say, I want a Ubuntu container, and I'll work with that for a while. We also use our Kubernetes cluster for that. Yeah, there's a couple of things I want to explain. Our use of namespaces in Kubernetes. I'm not sure if the previous talks talked about it, but you can namespace certain parts of your Kubernetes cluster, like these pods and services are within a namespace, and the other one, you can do whatever you want. We namespace all our different components, our microservices, the core monolith, etc. And we also make a distinct difference between production pods and staging or development pods, which is something we decided to do. It's not used, not common practice. If you look at the examples of Kubernetes, they often say within the namespace for your core API, you have your pods, and the stable pods have a label called stable, or the track is stable, and you select on that. That's something we didn't decide to do, mostly because of our legacy when we're used to using production development staging. But we're actually quite happy with how we do this. I do want to say we switch namespaces a lot. On my daily day, if I'm working on different projects, I switch my namespace configuration maybe 30 times a day. So one pro tip is get a tool for that, because having to write -- namespace every kubectl command will get tedious at some point. Yeah, we usually go for one namespace per project or service, and it's almost always tightly coupled to the GitHub repository, where the code lives. So if you have a namespace with crashing pods, we can check the code out, because we know where that lives. It works really well. Yeah. I want to talk about deployments at Blendle. How do we deploy to Kubernetes from, in our case, CI? Because you don't want to manually say kubectl apply every time it changes there. One thing to know within Blendle, we use the scripts to rule them all theory from GitHub. Basically it says every project, every repository, if it has a script/test command, that runs the test for this project. And if it has a /deploy command, this deploys this project. So if I get an arbitrary repository at Blendle, I just know how to run the tests. It's always this command. And that's really useful for development and in bigger teams. But CI also knows this. We're running our own Jenkins setup, which is very aware of this, and it's also aware of our Kubernetes cluster. And if it sees a test, it knows how to run that repository's test suite. If it sees a deploy, it can deploy when it's merged to master. And our Jenkins setup, which is built by one of my colleagues, it has all the secret it needs, and it's very easy for us to make a new deployment, or new microservices, which is automatically deployed by CI. And previously, we did this with Travis and Worker, but we decided to go for our own setup because we had a really specific deployment system, and already having all your secrets in there is really useful. So for us, if I make a new project, I make sure there are tests and that the script deploys the Kubernetes resources. Yeah. I'll show some more on how that looks later, actually on the next slide. One fun fact is that our Jenkins setup is autoscales in Kubernetes. It runs in its own Kubernetes cluster, And for each job, it just spins up a few pods. So we don't have a queue at Blendle, and CI queue. It just started immediately. It's really nice. I'm going to talk about two types of deployments at Blendle. One is our large project, our core monolith, actually, in which all the resources are in GitHub itself. Like all the YAML files you're used to see in the previous slides are in GitHub itself and are reviewed, code reviewed. Secrets are fetched from our password store every deploy, which is encrypted in GitHub with PHP. What CI does and what I can do from my local laptop is says script deploy production. And in there, it will put all the secrets in the YAML files and apply that on Kubernetes. Because it's a big code base, it took us over 2,000 lines of just resource files. But this includes also a preset local copy, which you can run locally. So if you use Minikube, if you don't know this, look it up. It's an amazing tool to learn Kubernetes. If you run Minikube in your local machine, you can also deploy our entire core monolith with all its dependencies and services and databases. That's why there are so many lines of code. And it also includes our sidekick and our proxies and Nginx and another caching layer, etc. So it's an entire stack running Kubernetes there. We also have smaller deployments. Another example is a Slack bot that updates, pushes an update every day at 4 o'clock. And only its deployment resource files in GitHub, and I just initially added the secrets and created the namespace. And it also uses script deploy production, or if I wanted to do for development. So in this case, the secrets I need to manually add. But if this breaks, if the secrets is removed, I don't care. We don't get an update this day, and people will complain after a few days missing it, and I'll fix it. It happened once, and it took them a week to actually notice it. So here's an example of that resource. The update premium bot. In this case, it was important to have one replica, because otherwise it will put multiple updates. In this case, I couldn't care less if it were just destroyed due to a preemptible node, because it's not an important piece of software. One thing I want to show is that we use substitute variables in our resource files. So in this case, it's only the version of the image built by CI. But if there are settings for this type of environment or the secrets, we always run a preprocessor for the resource files, which just injects environment variables in there. So that's really useful. Actually, our recommendation system, which uses all these processors, they all share the exact same resource files, and they generate them for each processor. They only have different names and different inputs and outputs and a different Python class to call. So we generate over 30 types of resource files based on one YAML file. So being able to dynamically put stuff in your YAML files is really useful, and we use that a lot. Kubernetes, we like it a lot. It results in an amazing stack, which is very fault tolerant. As I say, all our nodes, most of our nodes die every day, a couple of times, and we don't even notice. Currently, our DevOps team consists of 0. We have a student who comes in 1 day a week to do some stuff, but most of our developers just edit their Kubernetes deployments if they need to. I actually have on my team a data scientist who edit his own deployments. And then when he does, he asks in the code review for a more DevOpsy person to check it again. But he does his own scaling and his own Kubernetes. So with Kubernetes setup, we really have very little ops in our company of I think over 50 developers. I think that's a pro because the smaller the gap is between developer and ops, the more stable and more responsible the software runs. We're still looking into a couple of things. Monitoring, for example. We still often have certain pods running in a crash loop whilst we didn't get alerted, so we're still working on that. And another thing we're still finding our way in is how to do jobs, scheduled jobs, because you don't have one host with a cron tab which runs host. So some of our pods just run cron in them, but that's a lot of overhead. And the example of the Slack bot, which I'm kind of ashamed of, it just in the Python sleeps until it's 4 o'clock. It does its thing and then waits for a minute so it doesn't do it twice. It's horrible. Yeah. It works though, it never failed. And in going from wintertime to summertime, there was only one thing that wasn't affected, was this thing, because it did have time zoning. So it works. Okay, some closing notes. As you can see, we like Kubernetes. We have 9 nodes. We have almost 80 namespaces. We have 55 public load balancers, over 100 services, 250 deployments, and over 500 pods running right now. Running right yesterday. I updated this yesterday. A lot of developers use it, not only the DevOps guys. So my tips is, if you're using namespaces, get a quick switcher. There's one on the next slide. I've aliased the kubectl command to just k space get pods. Get autocomplete enabled for kubectl because it lets you explore everything, all the types of resources. Basically get comfortable with the kubectl command, play a lot with it, and then use minikube to run locally. Because then it also works on a production scale. It works really well. So that was kind of my story, what we do at Blendle. So thank you for your time. Are there any questions? Yeah.
Hi. You mentioned the health checks, right?
Yeah.
In Kubernetes, we have 2 types of health checks, liveness and readiness. Can you tell us how you use those health checks?
For most of our applications, because we are still improving on this, we just use the health check, which when it's healthy, it will decide, well, now it's ready. And for our stupidest health checks are just an endpoint returning, okay, I'm good. There are some pods which don't run HTTP service. We just run a command to check if everything's still running. And for example, for our recommendation processors, there's just a script in there that checks if the Python processor is still processing, if it still connects to the database and other sources it needs. And it's called as a health check, and it's called as a readiness. It's called as a readiness check first. And then it's called with a different argument for a health check to see if it's still running in the long run.
Thank you.
Okay. Any more? Yeah, there's one.
Actually, would like to know what made you change from different providers, from bare metal to Kubernetes. You have multiple providers. So what made you change these?
So we went from bare metal to cloud, because we were getting sick of managing a database, and that's not a job we wanted to do. We wanted to sell articles. So we wanted to make use of the managed tools. And we really got into containers, and we really saw the potential of isolating code, and we really liked it. So for this side project, we just did an experiment with Kubernetes, and we got so happy. We were so happy with that, we just decided, well, let's do this and just move to Kubernetes with our platform. Yeah, cool.
More questions? No?
Thank you.
Okay, well, thank you, Koen.
Yeah.